For chapter 4, page 124, number 58, we have a 48.3 kilogram sign that is suspended by two wires, and they give us a drawing. They tell us that it makes a 55-degree angle here and a 45-degree angle there. Now, we can't assume that this is going to be congruent. They're not going to have the exact same tension. This is going to call tension 1. We'll call this tension 2. And we're trying to find the tensions in that. We can use our law of, remember from geometry, because this is 55 degrees, the alternate interior angle here is also going to be 55 degrees, and we can add the little 43 degrees here. And then what we start doing is we try to create our equations to see what's going on. We need to add one more force, which is the force of gravity. Force of gravity pushing down. And our force of gravity is going to be 429.68 newtons pointing down. We just did that by taking the mass and multiplying it by 9.8. So we have all our vectors drawn, so we can try to come up with our equation. Now, the other things we know is that the net force in the x direction is going to be 0 because this isn't moving up or down, hopefully. And the net force in the y direction is also going to be 0 because this isn't moving. Again, it's not moving around. From there, we can start creating our equations. So we know that our net force in the x direction, because the only two forces acting in the x direction is the x component of tension 1 and the x component of tension 2. So we know they have to somehow equal each other and cancel them out. Then if we look at the net force in the y direction, it's going to be negative 429.68 because of our force of gravity plus our tension 1 in the y direction, because that's going to be pointing up here, and our tension 2 in the y direction, because that's going to be pointing up there. Now we have four unknowns. We have 1, 2, 3, and 4 unknowns and only 2 equations. So what we have to do is we have to make our equations a little longer, try to minimize our unknowns. The way we do this is we look at T1, and T1x is going to be equal to whatever T1 is times cosine of 55. And T2x is going to be whatever T1 is, sine of 55. So if we plug it in here, we can say that negative 429 plus T1 sine of 55, right? Because we just switched these two. And we can do the same thing for T2. Oops, sorry, this should be T1 x and T1 y, and then we can actually find out T2y, and then we say T2x is equal to T2 cosine of 43, and we gotta make sure to put in a little negative there because it's pointing, it's pointing this way. And T2y is going to equal T2 sine of 43, and that's going to be positive because it's pointing up. So when we plug that in, we get negative 429 plus T1 sine of 50 plus T2 sine of 43. And then our fx is going to be, instead of T1x, we're going to say T1 cosine of 55 minus T2 sine of 43 is going to have to equal 0. That means T1 cosine of 55 equals T2 sine of 43. Now if we go into our calculators, we can simplify this, or we can say that T1 is equal to T2 over sine of 43 divided by cosine of 55. And we plug that into our calculator, we get T1 is equal to 1.189 T2. So then we can take that T1 and plug it in here, because remember now we have less unknowns. And what we ended up getting from here, once we plug everything in, we end up with this equation down here. All I did was switch out the T1 here with this, which we came up from here. We just substituted. And then we can solve the equation. We can simplify it again. We end up with, when we multiply sine of 55 with 1.89, we get 0.97. And sine of 43, sorry, it's just 0.682. So now we combine like terms. Oh, that came out weird. We combine like terms and we end up with negative 429 plus 1.65 T2 equals 0. Then we solve for T2 and we end up with 260 newtons. And once we have T2, we can then plug it in back here and find our T1. And we find out that 260 times 1.189 gives us 309.14 newtons. So then, unless I didn't make any mistakes, there's our two tensions